All right, how's everyone doing? You good? Enjoying the event? Cool. Should we keep the doors open or I think, yeah, we'll close the doors. I don't think anybody else will be coming. Okay, cool. So if any of you is here to see a presentation on like how to build code sharing applications for web and mobile, then you're in the right place. And like you see the hashtags, we'll be using Angular and NativeScript for this. So that's like a quick preview. If any of you is on Twitter, that's my Twitter handle. So any pictures it will be appreciated. I might even give you some free stickers later if I find any. But yeah, a little bit about me. I'm Sebastian Vitales. I work for Progress as a senior developer advocate. And I've been involved with NativeScript pretty much almost from like day one. Like even back then when it was like version 0.2 where we didn't even have a markup to describe the UI or anything. So I've been like working with it from very early days, and like I hold NativeScript very dear to me. So this whole thing is basically a story that revolves around NativeScript, and I'm a pretty big fan of Angular itself. So let's get me started. For those of you, so basically this session is not about me explaining what NativeScript really is. Hopefully you will be able to see that from some other sessions. But in case you're not fully aware, NativeScript is basically an open source framework that allows you to build mobile applications. And you use web technologies, such as JavaScript. You can use Angular, Vue, CSS. And what you get out of it is basically native applications with 100% native UI and a native user experience. Okay, and this is basically the key thing over here. So we're gonna basically be talking today about code sharing. So how can you combine web and mobile together? And basically the goal of this presentation is, bless you, to achieve something like this, like have a single project that allows me to deploy for Android, for iOS, and for the web. Okay, that's basically the idea. And if that doesn't explain what I'm trying to achieve, is basically maybe something more like one project, two dogs. Okay, I usually get more laughs for that. Come on, guys. There you go. That's a better joke. Okay, so the way I envisage always like doing a code sharing is basically through a combination of NativeScript and Angular, right? NativeScript gives me access to build for iOS and Android, while Angular gives me ability to build web applications, okay? But not only that, Angular also gives me an architecture that is very code sharing friendly in so many ways. And I would like to explain some bits of that. So for example, how does an Angular architecture help us? Well, one of the things is like the data binding and the way the syntax in Angular itself works. How many of you actually ever used Angular? Okay, for how many of you this is completely new? There's a bunch of you. Okay, let me explain you some stuff. So the way you write code in Angular to render something on the web is not just like pure HTML. Like they have additional, let's say, syntax that allows you to achieve some additional tasks, right? So for example, the way data binding is done with what your variables values are in the component versus what gets displayed in the UI. They have a special syntax for binding those. So for example, you could do some sort of property binding or event binding purely by adding additional syntax. So for example, if I have a value in my component, I could use like the curly braces around here and just say the name of that value. And that will automatically in the UI display it for me. Or I could assign it by using like a square bracket around like a property name and say, get the value for this property from that variable. If I have, let's say, a function inside my component, I could use, for example, around an event like on click or on tap or on swipe. I could just use the regular brackets and then provide the function name that I want to call, or even do like a two-way binding. So in case you could, for example, get the data from your variables, but also if you change the variables from the UI, you could automatically push it into your component. And the important thing is that pretty much just this very simple syntax, you could achieve it without Angular, but it's not so straightforward. Like pretty much for each of those, you'd probably spend like 2-3 extra lines of code. And Angular basically makes it a lot simpler for us, okay? And that's really, really cool. But the cool thing also is that all of this is very generic. It's not necessarily like in here I'm saying like we're sending operations between your DOM or your native layer to the component, because the Angular allows us to kind of translate into different platforms. And this is done through the thing that they call the renderer. So for example, so the component is where your JavaScript, your TypeScript code goes. The template is where your HTML goes. So what happens is we have this renderer that has a bunch of different methods. So things like what happens when I want to create an element, or when I want to set an element's property, etc., etc. So basically, the component and the template together, they communicate with the renderer, and then as a result, something happens in the DOM, and then that gets propagated to the web browser. So what I mean here is, for example, if Angular says, hey, I want to create this component and put it over here in this page, then this component will go to the renderer and say, okay, I want to create element, so let's execute that. Then Angular will know how to perform this operation on the DOM in the browser, right? So it will tell the browser how to construct it, and it goes over here. And then very similarly, we could then basically do the same thing with NativeScript. So that's what we did when we introduced Angular to NativeScript. We basically re-implemented the renderer. So all the templating and all the syntax and all of that remains. But now if I want to add a NativeScript component somewhere on the page, basically we're executing the create element using our renderer, which then actually creates the component in a mobile application, and then as a result, you get like a beautiful native UI, right? So the whole idea is like exactly the same syntax, and then the same kind of like render, but the actual implementation underneath is taking care of us. So that's basically how we can achieve something that's platform agnostic. So let me give you an example. Imagine you wanted to create like a simple page with like a player component, and the player will have a name, Sebastian, and a Twitter handle, Sebawita, and then you have some sort of function like say hello to. So if I pass in a name, this will respond with a letter saying hi, and whatever this value is here, right? Super simple component. So that's our TypeScript. And then if I'm building a website, I could use the syntax just like this. So I could say, okay, let's add a div, and then on my name, I'm using the double caret braces. So in here, I'm going to display what the name was. So this is going to be Sebastian. Then for Twitter, I'm using, again, the binding syntax, which is called interpolation, by the way. And that will basically display like @Sebawita. And then finally, you see, like I'm binding to the click event by just like putting in brackets. And then I'm just calling say hello to web. And basically by doing something like that, I'm building like a one page of web application, okay? What I can do also from the very same component, if I wanted to do it for NativeScript, I could use syntax like this. So, bless you. So in this case, obviously NativeScript doesn't use the same markup as you have in HTML, because they're native UI components. But in this case, I want to display all my stuff through a bunch of labels and buttons. And here's the interesting thing. So for example, here, I'm binding to the text property using the square brackets. And then in here, I'm passing my name, I'm passing my Twitter. I have a button. So in here, I was calling the click event. In NativeScript, on mobile apps, you don't click, you tap, right? So on tap event, I'm calling exactly the same function, say hello to, and then passing like some sort of string in there, and that renders. So this is the really cool thing. Like the component code that I was showing you before works both for this and for this. It's just the UI that's different. That's pretty much the idea. Another very useful thing in Angular that allows us to do code sharing is dependency injection. Which comes handy in many ways. And dependency injection, for those who don't know much about it, it's basically this concept of you have some sort of engine that takes care of your services. So services could be something that could take care of your login system or your data or like communication with, I don't know, security or encryption, etc., etc. And usually you don't need 10 copies of the user service, right? You usually need one. So if you use the same service across different pages in your website, then dependency injection makes sure that you only ever create it once, and you always give you the same copy across. But also it allows us to kind of inject the right types of services as we go. So here's one thing. Most of our applications will pretty much be connected online somewhere. So you'd most likely be making HTTP calls to get the data or maybe push updates to your backend, right? And the thing is that how the HTTP is implemented in a web browser is completely different to how it is actually implemented on a mobile. And even between iOS and Android, they're completely different, right? So how can we solve that? So here's the thing. In Angular, if you want to make any HTTP calls, they have this thing which is called HTTP client module, okay? I'm not going to be diving too deep, but like just to give you an idea. So the HTTP client module knows basically how to make a get or a post command and then kind of handle the results and parse the results. So in an Angular application, you have this thing called the ng module, where you declare all the things that you will need for your application. So we say, okay, we will need an HTTP client module for our web project. But then for NativeScript, what we did is we have an equivalent. So if you're building a NativeScript application, then you can import a NativeScript HTTP client module, right? But which has exactly the same thing implemented underneath. So what this really means that both of those modules prepare my application to be ready to do HTTP calls at one point in the future, right? So the cool thing is this. I can, in my actual component or maybe in my service, what I do is I use dependency injection. So over here, I'm saying I want to use this HTTP variable, which is of type HTTP client. And that's how I'm telling Angular, say, hey, go and get me HTTP client from somewhere. And that somewhere were basically either the HTTP client module or the NativeScript HTTP client module. And then later on, I can basically go and grab my HTTP variable over there and call that .get or .post or et cetera, et cetera. And the really cool thing is that this class over here will work with both ng modules, the NativeScript one and the web one, right? So again, I can share all of that. So all my business logic that deals with my backend could be written once. I just have to kind of using dependency injection that if I'm building web application, use the web version of the HTTP client module. If I'm building a mobile app, use the NativeScript version of it. And I think that's very, very powerful. And I'll show you later on also an example of how that looks in practice. So code sharing project structure. So when I started on this project, I kind of envisaged it as like one big mono repo where like I just drop everything in there. So like anything that deals with the navigation, my services, like directives and pipes, those are very like Angular specific. But even like with my styling, like I could maybe share some of the styling, but then I would have even style sheets that are web and NativeScript specific because you may want to style your web and mobile apps in slightly different ways. Then all my components. And components, most of the time, they're like what, for each page you would have one component, for example. So the TypeScript class of each component would be shared, but the markup, the UI for the two of them would be separate. And then same thing, in Angular, we have the concept of modules. So what you can do is group certain pages or certain components together. So that, for example, when you load the application the first time, you're not going to load every single page in memory, but only, module by module, okay? But again, in a code sharing project, you can share all the components that belong to the module and the module's navigation, but what goes in terms of resources into those ng modules will be separate. Like, for example, the HTTP client module, right? You have the HTTP client module here and the NativeScript HTTP client module inside here. So this is basically like this mono repo that kind of like has all the files together and all the components, all my modules with a way to separate like web and mobile files. And what I need from here is basically some sort of build process that is then capable of taking all the shared files and maybe, let's say, the web-specific ones and build me a web application, okay? Or let's skip the web-specific files and take shared and the NativeScript files and build a NativeScript application. So this is basically like the theory and the idea that we had at the beginning, and we had to basically try to achieve something like that. Oops. Okay, so code splitting. So obviously I was showing you like, yeah, I want to have 2 markup files for each of my components and maybe 2 style sheets. Like, how do we achieve that? So if I have this super basic component, I call it name component, which has 2 files, name.component.ts and name.component.html. I kind of expect to share this one. I want to have 2 versions of this. So what we can do is basically use this naming convention by adding a second file with a .tns over here. I'm kind of saying this is going to be a NativeScript specific file. So now I have name.component.html and name.component.tns.html, and this .tns is the key over here. And if I want to add 2 style sheets, no problem. I can add 2 style sheets, and one is .css, the other one is .tns.css. And pretty much any file in a project, I could use the .tns or not. If I wanted this style sheet to be shared between the 2 of them, I just would create just this file, but not this one. And then this would become automatically a shared file. But as soon as we have 2, we do in sharing. That's kind of like the syntax idea. So how do you even get started? Like, how can you create a new project, or what sort of things can you do? Because obviously I was saying like, we need all those things, and how do we put this in practice now? So what you can do is like, in Angular world, there's this thing called Schematics, which is kind of like, in the simplest words, like a small engine that allows you to manipulate files, really. It's something that you could execute like a bit of code that could, for example, add you some new files or maybe change some bits inside the file. So what you can do also is, so we created this schematics that has, let's say, scripts on how to create a new project in a code sharing structure or do some other things. So if you install using npm at NativeScript/schematics, you have basically everything to get started with code sharing. Okay, so you install that, and then if you want to create a new project, what you can do is call ng-new. So ng is basically the Angular CLI. So you say, I want to create a new project using the collection at NativeScript/schematics. Then you provide the name of the application. And then at the end, if you add --shared, you're basically saying, I want to create a shared project over here. So this is using the Angular CLI that is created by Google to create actually a code sharing project that involves both NativeScript and Angular, which is, I think is pretty cool. If you don't do --shared, then basically that will create you just NativeScript only project, by the way, if you are curious. Okay, so moving on. So how does this whole like build process work of a shared project? So if you want to build a web application for any Angular developers, it's business as usual. You could just call ng-serve, which will use the Angular CLI, which will give you a web application. It's super simple. If you want to build a mobile application, we are using Webpack for that process. Okay, so it's kind of like a 2-step process. So first you would run a command like tns run either Android or iOS, and then you say --bundle. And this --bundle saying we want to use Webpack for this particular build. Actually, probably very soon you might not even need --bundle because we go in 100% Webpack. But for now you need to add --bundle. And this basically runs in 2 steps. Okay? So first step, basically what happens is the Webpack will go and have a look at the project and then look for all the .tns files. And basically kind of like overwrite the non.tns file. So if you remember, we had that name.component.html file. And if there's also name.tns.html, the .tns gets removed, and this becomes our official home.component.html. And all of that basically happens in memory. So what happens really is in memory, we're taking the shared files and the NativeScript specific ones, and we're creating a NativeScript project sort of like in memory. And then as a second step, the standard NativeScript build process kicks in and then builds the application from that for us, which I think is really, really cool. So you don't really have to worry about it. You don't have to move files around or anything. All of that kind of happens in memory. And if that doesn't explain it well enough, I think this should. So if this tiger is our NativeScript build, and the DAC represent all our web files, basically Webpack will do something like this. See, the Webpack file. I think that explains it well enough, right? You know, you're building a NativeScript application, you don't want web files, they go. That's it. Okay, so what I will do now is jump in a quick demo, and I'll come back to the presentation later on, but I want to show you an actual project. So this project is on GitHub, so you can go and check it out later. I kind of like keep trying to update it, etc. So let me show you. Can you all see well what's on the screen, or should I make it a bit bigger? Okay, no complaints? Fine. So this project is based, so if you want to learn Angular and you would go to their website, they have this tutorial called the Tour of Heroes. And when you complete that tutorial, you have like a very simple single page application that kind of like allows you to show a list of heroes and maybe create a new one, etc. So it's very basic. So what I actually did at one point, I decided to migrate that project into a code sharing structure. So this is basically a shared version of that project. So what I will do is build this project for you. So I can run ngserve-o, that's for open. nvm use 10. Okay, so I'm building a web project, and then also from here, I'm going to use NativeScript CLI, so tns run ios --bundle, and build a web application which will run in this emulator. So yeah, I already built it before, but you can rebuild it again. So here's what we have in this application. It's very simple. So this app, can probably even zoom in a little bit. It's very simple. You have like a label for my heroes. You have a bunch of heroes over here. I can delete one, or I can add, you know, Sebi with a smiley, etc. And then like Sebi's over here. I can click and then go into the details and then kind of change it to kind of something, you know, of a surprise. And that gets updated. And there's like a dashboard where I can search for individuals heroes. So like, yeah, if I say SE, yeah, there you go. We found Sebi over here, and I can navigate. Like, it's a very, very basic application. So the mobile app is built. So I will do something like this, maybe. And so this is the, come here. Drag it, okay. So this is basically an equivalent application. And here's one very important thing. At no point did I want to make this application absolutely identical. I want the essence of the application to be shared, but there's some small differences that were intentional in my design. But let's have a look. So in my mobile application, I also have a list view. I can also add, you know, Sebi over here. Oh, Devi. That's not very helpful. But yeah, let's make it Devi, and Devi will appear at the bottom. I can destroy Tornado and Dr. IQ. And then also like I'm using like a side drawer to see like other stuff, like, you know, I see a dashboard, and I can also search for like Devi, and then you come up, etc., etc. So you see, like, it's pretty much like very, very similar application. But for example, I made a different choice of my navigation. In here, my navigation is always on top. In here, I'm using like a fancy side drawer, etc., etc. Like, for example, in here, I'm always displaying the messages at the bottom, while in mobile applications, the space is, you know, worth the gold, like the gold of like my weight probably. So I can't just keep the log at the bottom everywhere, because that would be kind of useless. So I kind of create a separate component. Okay, so let me jump in the code to explain how this is constructed and how this is built. Fine. So one of the first things is, I was talking to you at the beginning about this ng modules that we have. So one of the first things that we have is, for example, we have this HTTP client module that is responsible for getting the data, okay? So I have this app module.ts, so that's the web version of the project, in the project, but also I have second app module.tns.ts, and this one imports NativeScript HTTP client module, right? So through dependency injection, I am telling my project that to use either this one or this one. And like I was telling you before, what will happen when I build this project, for example, for mobile, this will become my main app module. And automatically I'll be using the NativeScript HTTP client module, which is pretty clever, right? So next thing is, for example, I have my data service. Let me see. So I have, a hero service, and basically this is the service that grabs the HTTP client, like I was explaining, and you see there's only one copy of the hero service, no other ones, right? And then in here I have methods like get heroes, and get heroes uses the HTTP to call get and gets records. Maybe have another one. We have get hero, so if you pass in an ID, we'll get a specific hero. Or you could have like a search function that if you provide some text, it'll give you a list of available heroes with that. And this is the really cool thing, because yeah, you have like add, delete, etc. The cool thing is that I provide this business logic in just one place, and then it will be available for both parts of my project. So next thing is, for example, let's have a look at heroes component. So heroes component is basically this component here that we see, this page per se, that has like all the heroes listed, and we have like a way to add a hero or list them, etc. And the heroes component is very simple. You have like an array of all the heroes that are available. You see we use dependency injection again to use the hero service. So for example, when this page loads, I'm automatically calling get heroes, and then like basically getting all the heroes provided from the HTTP. So once I have those heroes, then I can go and display them later on. Also, I have like functions like if somebody types to add a hero or delete one, you just provide either a name or the hero object to perform that, right? I'm not gonna dive into those exactly. So what happens here now is I'll have two HTML files, okay? So the first one, and I will show you quickly, is this bit, for example. This my heroes, hero name, and the add button, right? So this is this bit over here. So we have like an input, so that's for the text field, and then we have a button that has text add, but also when we click, we actually calling the add function and providing the hero names value, right? So we say, okay, let's get the name from the text field and call the add function from my component, okay? And the second thing that we have here is we create like unordered list. And this is another really cool thing from Angular. There's like this ng4 that you could repeat the same thing over and over again. So say, let's redo the same list item for each hero in the heroes array. So that's how we basically display like the number, the name, and like a little cross next to it. And then we have this delete hero button. And that's basically, in a nutshell, that's the idea. But if there was one thing that is important for you to see from this slide, is the fact that, let's say, on those two buttons, for example, when we click, we either call add and then grab the value, or if you want to delete, you click and then call, for example, delete hero. And also that we fetching the data from the heroes array. That's the key that I want to show you. So this is how I built my website, okay? The web version of the hero component. And then for NativeScript, the syntax is different, the markup is different, but the component is the same that is underneath. So the first section is, we have this text field where we allow people to enter the hero's name, and then we have a button that calls on tap event at hero name.text, just like we did in the web component. then we want to display our heroes. We're not going to use an ng4 because ng4 usually renders every single item that you have in a list. So if you have 1,000 heroes, that will be a very long page. So we're using a list view where we say, okay, display all of them as like you saw the list view before, and the items come from heroes. And then for each of them, we're displaying like the hero ID, name. But again, when we tap the delete, we basically execute the delete hero function. And I think this is very, very powerful because, yes, I had to write this markup twice for web and mobile, but what happens underneath is only written once. And very often, the harder bit, it actually sits in the business logic. So if later on, like your application, you discovered a bug or some security issue, you fix it in one place and both applications benefit from that, or even all three of them because you have web, iOS, and Android. Let me show you a couple of other cool stuff. So there's another component, hero search. So not all components are pages. Sometimes a component could be just a section in our application. So if I go to the dashboard, you see this hero search and this text field. That's actually, that's actually a component by itself. And then when I type something like CE, that's also like part of the search component. And we have the same thing in both web and mobile. So in my dashboard over here, this part here, the enter hero name, yeah, let's do RU, and the result display, that's actually a component by itself, not it's part of the page. So what you can do is, and this is pretty cool, you have this hero search component that basically does something very similar, like it has a search function that every time you pass it a string with, say, like I typed CE, you execute the search, you kind of like you push it to like using RxJS, but basically what it does is performs a search internally, and it has this even debounce time 300 milliseconds, so that as you type, you only perform the search after 300 milliseconds elapse. But this is an implementation detail. But the important thing is like I have this clever way of searching my heroes using my service, and here's the important part. I have this selector called app hero search. So the app hero search becomes my markup now, okay? Also the hero search, what it does, it has two HTML files. So I'm not gonna dive in too deep, but the idea is that if this is a web project, then basically we have this input where somebody can type some text, and then we execute the search underneath, and then we display the results in that unordered list. And I do exactly the same for my NativeScript equivalent. So as well, like it will use the same variables and the same methods that the component has, but it just displays it the NativeScript way. And then finally, and this is the really cool bit, we start sharing components between web and mobile. So in my dashboard page, you see I have in the web, like all the web stuff, but the search is a component by itself. I'm just dropping a tag there, and then that injects that whole structure and the logic in there. And the same thing I can do with NativeScript, where I'm adding at one place in my application, again, the app hero search, and it's exactly the same markup. So you could even start building components that are shared between web and mobile individually, and that's very, very powerful. And that's pretty much the idea. Depending on the application, you can also make the navigation shared or not. It varies. So in my case, I have two configuration for my navigation. Let me just align it nicely. So depending on what type of application you build, you'll be sharing more or less. So in this case, my navigation, I'll have like ability to navigate to heroes page, dashboard page, or detail. While in my mobile project, I also wanted to have like a messages page that I wanted to navigate to. So in this case, I decided to have them split. But in many cases, you would actually have those even configurations shared. It really varies. So that's pretty much the idea of this project. There's a lot other things going on in there, but I don't want to dive too deep before it gets too advanced. Cool. So I hope that explained you the idea of like the code sharing project and how everything works and what sort of things you can do. And I do recommend checking it out. Next thing. So far I was talking about basically the idea of like how this whole thing works and how you would go about starting from scratch, creating a new project. What if you have an existing Angular project, right? So we have also a migration path so that you can convert your existing Angular project to web projects to a shared project, okay? And we're using again the schematics that I mentioned before for it. So what really happens is, imagine you have this web project that you created at some point in the past using the Angular CLI called ng-new, my app, and then you spend 6 months working on it and adding new features, etc. And then you want to add mobile to it, right? So what you can do is there's another Angular CLI command called ng-add. So if you call ng-add and then pass the name of our schematic, which is add NativeScript/schematics, what this will do is basically go have a look at the project, how it's structured, and you will restructure it to a shared structure for you, okay? And then after that, from this project, you'll be able to call ng-serve or tns run iOS Android -- bundle, okay? We also looking, and this is like in production. This is not in production. This is something I'm still working on, and I can't promise when this is going to be done. But we're also looking at making this the reverse. If you have a NativeScript project, to basically call like it's not ng-add in this case, but you call generate add web, which will convert the NativeScript project into a code sharing project, which again gives you the ability to either build web and mobile applications. One thing important from here is when we run this schematic, we are converting the project structure. We don't convert all of your project. We don't create, like the markup that you need for NativeScript is not going to be created for you magically. This is still something that you have to spend some time and put some work in there, okay? Because if somebody can write something that can convert HTML markup to NativeScript, I'll give them $10,000 today, seriously. I'll give more even. Anyway, but we have things that can help you achieve that, okay? So if you have, for example, this home component, we might want to migrate individual components one by one and then perform, and then add the markups and additional things that we need. So if I have this component, I could, for example, use Angular CLI to call ngg migrate component, and then you can provide the name of the component in that command. And this will take this component and then convert it into like a code sharing structure. So what this basically does is additionally adds like the .tns.html file and then .tns.sass, or if you're using CSS, you would add the CSS file. What also it will do, the markup that you had here, you copy it over to here and then comment it out. So what this basically allows you to kind of, without jumping between files, kind of see what sort of things you were doing here, and you can delete the individual sections as you edit the whole thing. And I think this is really, really handy. But obviously, if you have a very large application that you could have hundreds of components divided into the individual modules, this could be very slow if you do it just one component by component. So we also have a command to migrate a whole module, okay? So if we have like this menu module that has a component inside, it's got its own navigation and its own ng module kind of a configuration, you can call ngg migrate module this time. And if you provide the name of the module, something similar will happen. So first, all the components that were inside the module get migrated using the previous schematic. And then following that, basically we adding additional files like the ng module .tns.ts file. And then there's also like this additional file like the common file, which already has like some sort of structure that allows you to maybe share some of those configuration between the two modules. And I think that's also pretty powerful. So what I actually did, that tour of heroes that you saw just a moment ago, I used those schematics to migrate that project. So within, like, it's not a huge project. It had like 3 pages really. It took me 1 hour to get it into a working state, that every single functionality that you saw on the left in the web was also implemented on the right in the mobile. And then I spent like, a whole day doing the styling and making the application look nicer. But functionality, I had it migrated in an hour. And sure, like, I'm very experienced with that, and like, I know what I'm doing, but that's basically the idea. So like, I think that deserves a good fist bump and a high five. Right? Okay, so quick recap. Pretty awesome. I don't like cats, but I could have this one. I'm a dogs person. All right, enough. Just kidding. So quick recap, migration commands. So if you call ng-add/NativeScript/schematics, converts the project, and then you can use ng-generate migrate component or migrate module to help you migrate individual components and modules. Let you take a picture. And alternative solutions. So monorepo is just one way of doing it. And I kind of see what you just saw, I would use mostly for projects where both web and mobile are fairly similar, fairly close. If you end up in a solution that by design, you maybe share just 3 screens, but 20 others are completely different, then this might be an overkill. Sorry, not overkill, but this might not be the best suited solution. But if you have, if the functionality between what goes in web and mobile is fairly close, let's say, even if it's, let's say, 60-70%, you're already ahead of the game. However, if you're in a situation where maybe you just want actually even 4 different versions of the same mobile application and share code between different mobile apps or between different web apps between each other, then what you could use is NStudio XPlat, which is based on this architecture created by the guys from Narwhal. How many of you heard about Narwhal? Anybody? Few? Narwhal is a company formed like by a bunch of Googlers that used to work on the Angular team, and they left and they created a consultancy, and they created this whole architecture that allows you to basically share the code between multiple web projects or mobile projects, etc. So XPlat was built by NStudio, one of our partners, based on Narwhal's NX. So you can go and read a little bit about it. So now, like, this is for really advanced, like, very complicated projects. So if you're trying to build Tour of Heroes like I did before, this would be a massive overkill, right? Like, it's like taking I don't know, a tank to take out a tree, or like a little bush. Like, it would be an overkill. But it's very, very powerful. So especially for projects that they don't have too much of alignment, this is a good approach. Okay, if you want to learn more, I'm running a workshop today on this very topic that is hands-on. So you need your laptops, and also you need to do some installation. So the workshop is called Build Web plus Mobile Apps with a Single Project. And it's basically going to be me coding something in here and you kind of following what I do. That's like the idea. And it's not going to be a very complicated project, and depending how everybody goes, we might build, a lot of things or some things. We'll see how we do. But before you come, because the internet here is not probably the fastest, I would need you to install 2 things on your laptops. So if you have NPM, please go and install the NativeScript CLI, and also install Angular CLI. Because we use Angular CLI to create the project, and to generate like individual components, etc. And NativeScript we use for actually building the project. So if you're planning to come over, I would encourage you to run these 2 commands. You can probably find me later on if you're struggling. I'll help you do the installation. It's not difficult. It just might, at 3 megabytes per second, it might take half an hour, right? So yeah. And then as a last treat, this is my favorite. Thank you very much. The dog is cuter than the cat, right? Right? Yes. That's what I wanted to hear.